In this video, we're going to solve polynomial equations, specifically polynomial equations in one variable. However, as I've been mentioning, we can easily extend the concepts that we use to solve any of these equations in one variable to equations in multiple variables, because it's like if you're going to be solving an equation in multiple variables, you're going to pick one of the variables to solve for and sort of treat the other variables like they're constants. That's the idea. So all the mechanics, the principles that you use to solve that we learn to solve these equations with one variable easily extend to these same types of equations in multiple variables. Okay. Now, but we're solving polynomial equations in one variable. So what is a polynomial equation? Well, it's an equation where each term is a polynomial term. And now, but there is a bit of a distinguishment that needs to be made between, so if it's a polynomial equation to where every single term is degree 2 or lower, then we call that a quadratic equation. And if it's a polynomial equation to where every single term is degree 1 or lower, we call that a linear equation. And so with that, then, if you have a polynomial equation to where at least one of the terms is of degree 3 or higher, then we just call that a polynomial equation. Since we can't call it quadratic or linear, we just call it polynomial. Okay, so now, how do we solve polynomial equations? What's the general procedure? Well, what you want to do is you want to use the zero product property. We learned this for how to solve quadratic equations, but with quadratic equations, there was actually two other methods we could use. But when it comes to a general polynomial equation, you're just going to apply the zero product property. That's how you're going to solve it. Okay, which means that you take the equation, you expand everything out, combine like terms, put everything on one side of the equation with 0 on the other side, which means since it's a polynomial equation, you're going to have some polynomial expression on the left with 0 on the right. Then you just factor that expression, fully factor it, and then from there you set all the factors equal to 0 and solve for, and you're going to get all the solutions. Okay, and remember, polynomial equations are a type of equation to where if you don't make any math errors, then all the solutions that you get are going to be solutions when you plug them back in. There's no extraneous solutions that come into play here. Okay, now also just note that you might be thinking, well, what if we can't factor the polynomial, right? Because we learned how to factor in pre-algebra, and it seemed like there was certain scenarios where maybe we couldn't factor it. That is true, but we're going to, in chapter 3, we're going to learn some very powerful techniques that will allow us to factor any polynomial no matter what it is. So that's not going to be an issue. Okay, so we start off with a simple problem here to where it's actually already been factored. The polynomial's already been, kind of expanded out, combined like terms, brought everything to one side, factored with the factors equal to 0. So now we just use the zero product property. So meaning if minus 3x is equal to 0, then whatever x makes minus 3x equals 0, which we can see means that x is equal to 0, that's going to be a solution. Because if this is 0, then it doesn't matter what these two are. You multiply 0 times any number, you're going to get 0. So that's a solution. Okay, but now also any x value that makes 2x minus 1 equals 0 is also going to be a solution. So we add 1 to both sides. We divide both sides by 2. You get x is equal to 1/2. That's also a solution. Okay, now if x plus 6 is equal to 0, that's also a solution. But it doesn't matter that this is squared. It's the same idea. Just what value of x makes this equal 0? And so that's the 3 solutions. Okay, so now here it's a little more complicated in that they have everything's been expanded out, combined like terms, and put on one side with 0 on the other, but it hasn't been factored yet. So let's go ahead now we can just go ahead and factor this. When we have a 4-term polynomial, the go-to method is going to be grouping. And so we want to group like terms here. So we can group the 3 and the 75 and the 100 and the 4. So let's do 75y cubed minus 3y. That seems like a good match. Plus 100y squared. Y squared minus 4 is equal to 0. Okay, so now we take out a 3y here, and we get 25y squared minus 1. Okay, and we take out a 4 here, and we get 25y squared minus 1. So the grouping worked, which I know you might think, well, that's, it's always so convenient that the grouping worked, but it seems like in general the grouping won't work like that for a general polynomial. That's true. But when we get to more, in chapter 3, we'll learn how to factor any polynomial. All right, so we've got 3y plus 4, and then 25y squared minus 1 is equal to 0. So we can write this 25y squared minus 1 as 5y squared minus 1 squared. Okay. So now we have a difference of 2 squares. So which we know we can write that as like this. Okay. So now we're fully factored. We haven't changed this expression on the left. So if 3y plus 4 equals 0, that's going to be a solution. So y is equal to minus 4/3. Okay, if 5y plus 1 is equal to 0, that's going to be a solution. So y is equal to minus 1/5. Okay, now if 5y minus 1 is equal to 0, that's going to be a solution. Y is equal to positive 1/5. And there we go. There's the 3 solutions. Okay, so here we're starting with a more general equation. So, one way to think about if you're trying to solve an equation is you expand everything out, bring everything to one side, combine like terms, and then you'll be able to identify what you have. That's like one term you can use to think about this is it's like you put the equation in a general form where you expand everything out, bring everything to one side, combine like terms, and see what you have. So subtracting 4x from both sides, right? So we can see here, okay, we have a polynomial equation. So if we factor this, so 7, oh no, we can't. Okay, we need to do grouping here. So it could be, we could group it either way. So let's just start here and see what this does. So x plus 7, and take out a minus 4x plus 7, that works. Okay, so x squared minus 4, x plus 7. All right, but now we have a difference of 2 squares. Okay, so we see that x equals minus 2, x is equal to 2, and x is equal to minus 7 are all solutions. Okay, so here, it's tempting to do this. And actually, in this case, I think this would work because it's only, we don't want to do this and start dividing both sides by x. Then that's why that's not it's foolproof if you just factor if you bring everything to one side and factor it with a polynomial equation. But actually, this would work out. So yeah, like here, I've mentioned this before, but if you have a case where if we're only considering x to be some real number, there's only real number solutions, then you actually can do this. Take the principal fourth root of both sides and do this plus or minus like that, and that actually will work. 2 to the 4th is equal to positive 16, minus 2 to the 4th is equal to positive 16. But it's really only the case where x has to be, you're only considering real numbers. with the square root property, they made that an official property because you can really apply this across the board. X can be imaginary, and it'll work in all circumstances. But they didn't give us any official property with like a fourth root or even roots other than 2 because it doesn't work across the board, so they just didn't even go there. But I am saying if you do want to, if you're considering X to be just a real number, only potential real numbers, then you can think about, okay, I can put like a principal nth root on both sides, and if it's an even root, do a plus or minus, and that'll work. But let's just go through the standard method of factoring. So, because that's foolproof. There's no kind of issues that come up doing it this way. So we factor out a 2. We've got this. Okay, so we've got this is x squared squared, and we've got, so a difference of 2 squares here, x squared minus 4, x squared plus 4. Okay, now we have another difference of 2 squares again. Okay. So, all right, there's no real number when you square it and add 4 to it that you get 0. So the only solutions are going to be there. Right, yeah, so here, it's tempting to divide both sides by 2x. Right, and you can do that, and you'll get a valid answer, but there's going to be missing solutions potentially, because x can't be 0 when you do this. But we can, so no matter what we do after dividing both sides by 2x, we're never going to get the result involving 0. But look, x is equal to 0 is the solution, right? Plug in x is equal to 0, you get 0 equals 0. So that's why if you do the zero product property method, you're not going to lose any solutions. So, okay, let's factor out a 2x. So we've got x cubed plus, let's see, what is that, 64? Okay, so now here we've got a sum of 2 cubes, right? So we can use the sum of 2 cubes formula. That's, so a plus b cubed is a plus b, and then a squared minus ab plus b squared. So, okay, x plus 4, and then x squared plus 4x plus 16. Okay, so we've got these 3 factors here. So x is equal to 0 is one solution. X is equal to minus 4 is another solution. And here we need to solve, this is a quadratic equation we can solve, like x squared plus 4x plus 16 is equal to 0. And wait, I'm not sure. I think they wanted us to include the imaginary solutions here. So we can go ahead and do that, actually. Let's come back. So, okay, yeah, if we say x squared plus 4 is equal to 0, we can solve this. So x squared is equal to minus 4, square root property. So x is equal to plus or minus 2i. There's more solutions. Let's see, what else? No, there's no imaginary solutions there. So, okay. We had these additional 2 imaginary solutions. Now, we're going to have 2 more imaginary solutions, because if we look at the discriminant here, right, b squared minus 4ac, if we're using the quadratic formula, then we have 16 minus 4 times 1 times 16. 16 times 4 is 64. 16 minus 4 is minus 48. The discriminant is negative. That means we're going to have imaginary solutions. So let's see. X is equal to minus b plus or minus b squared minus 4ac all over 2a. So 48 is 24 times 2, so 6 times 4 times 2, so that's 3 times 2 times 2 times 2 times 2, so 3 times 2 to the 4th. So we've got minus 4 plus or minus, and we can take out a 4. So 4I root 3 over 2. So x is equal to minus 2 plus or minus 2I root 3. And there's more solutions. Okay, so let's see. Let's just distribute everything and then bring and combine everything on one side. So 3n to the 4th plus 9n squared is equal to 20 minus 2n squared. So 3n to the 4th plus 11n squared minus 20 is equal to 0. Okay, so now let's factor this, and what we can do is we can say that if we say u is equal to n squared, then this is 3u squared plus 11u minus 20. Okay, so 20 times minus 3 is minus 60. So we've got 6 minus 6 times 10 minus 6 times 5 times 2 minus 3 times 2 times 5 times 2. So let's see what we have here. 15 and a 4. Okay, that'll work. So let's see. But, okay, can we do positive 15 minus 4? So, okay, there we go. So let's do plus 15u minus 4u minus 20. Yeah, that's going to work. So, okay, take out a 3u here. You have u plus 5. Now take out a minus 4. Here you have u plus 5. So there's 3u minus 4 and u plus 5. So since u is equal to n squared, what we've got is 3n squared minus 4 and n squared plus 5. Okay. So now let's just do, so 3n squared minus 4 is equal to 0. So 3n squared is equal to 4. Divide both sides by 3. So n squared is equal to 4/3. Okay, square root property. So we've got n is equal to plus or minus 2 over root 3 multiplied by root 3 over root 3. You've got, so yeah, n is plus or minus 2 root 3 over 3. Okay. Now we can do n squared plus 5 is equal to 0. So n squared is equal to minus 5. Square root property applies in all circumstances. So we've got n is equal to plus or minus I square root of 5. And there we go. Okay, so this is already kind of laid out for us. We can say w squared minus 7 is equal to 0. So w squared is equal to 7. Square root property. So w is equal to plus or minus root 7. The square root property works in all circumstances. If you have an equation, no matter if it's complex, whatever, you can always, you don't even have to think about it. If you add a square root to an equation, to both sides of an equation, you can do it no matter what. Put a plus or minus, have the variable on one side or plus or minus on the other where the numbers are, you're good to go. Okay, like here, w squared plus 4 is equal to 0. Okay, well, you subtract 4, square root property. W is equal to plus or minus 2i. Okay, so yeah, let's see. Here, we can use a trick here. So, okay, we have a difference of 2 cubes on the left. So that's going to be, it's x cubed minus 2 cubed, which we can write that as x minus 2 and then x squared plus 2x minus, and then 2 squared is 4. Or no, this would be plus. Yeah. Is equal to x minus 2. We could put it in parentheses like that. And so from there, we can do this. This is just like a little factoring trick. We can subtract x minus 2 from both sides. Okay, but now we can factor out an x minus 2. And so we'll get x squared plus 2x plus 4 minus 1, which is going to be just positive 3. So yeah, we could factor it that way. Okay, now it looks like we can still factor this here. So minus 3. No, it looks like we cannot factor that. So, okay, that's fine though. X is equal to 2 is going to be a solution, but now let's use the quadratic formula to solve this. So minus b plus or minus b squared minus 4 times a times c all over 2a. So minus 2 plus or minus 4 minus 12 is minus 8. So minus 2 plus or minus 2i root 2. That's square root of 8 is 2 root 2 over 2. Okay, so x is equal to minus 1 plus or minus I root 2. And there we go.